All right, hello. Welcome to lesson 9.4. And this chapter, the chapter shifts now a little bit when we hit 9.4. So far, we've been doing something called sequences, or like a arithmetic sequence of numbers is like, start with 7 and add 3 each time, right? That's basically an arithmetic series, all right? And arithmetic sequence, and we're gonna shift now in 9.4, we're gonna do series. And so the difference is basically it'll be a pattern like this, same as before, right? We'll have not zero, we'll have the positions and then their values. So this would be like the first position, second, third, fourth, fifth. Okay, so this would be a sequence, what you see right here. But what you do with a series is you just add these together. So today we're going to do arithmetic, which will be a plus minus pattern, and then a series, which will be just to add them together. In this lesson, then we will be figuring out how to calculate these sums. It'll be another formula, all right? And so I would definitely have a calculator out. And then at some point too, if you want to start referencing the formulas for this chapter, there's a digital version of it right here in the chapter 9 folder. So there's a ton of different formulas, but the one we're going to do today is for arithmetic series. So if you look at the formula sheet, if it ever loads here, the formulas we'll use today is we'll use the explicit formula for arithmetic sequence here, and then we're going to be finding the sum of a finite series. This is going to be the formula for today's class. So make sure you have a calculator out, and again, if you want to reference this formula sheet during the lesson, might be a good thing. Okay, so first thing is just to get the vocab down. So remember we're talking about sequences and series, all right? And sequences look like this, where you're not adding them together. And then a series is when you actually add them together and find the sum. All right, so here, this series, you add all those together, you get 60, 6, 9, 12, 15, 18. And then there's two different types of sequences series, and there's called infinite ones, where they go on forever and ever and ever. And then finite means they stop. So like this first one's finite, this one's infinite. Okay, and the same thing with series. So you might have a finite series here, and then you might have an infinite series, which, believe it or not, you can actually find the sum of some infinite series. This one you couldn't, because they just go on and forever and ever and get bigger and bigger, and you'd have no sum. But anyways, that's called an infinite series. So I have some practice questions to make sure we've got that. So take these examples, and are these series or sequences, and are they finite or infinite? Pause the video and give it a shot here. All right, so the top one ends. There's no dot, dot, dot. There's just 5 terms, so that's finite. And you're adding them together, so that's a series. Second one here, you're not adding them together, so that's a sequence. And then there is a dot, 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 so it's infinite. Look at that spelling skills. Look at that. All right, let's spell it right. And then the last one would be it's dot, 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 so it's infinite again. It goes on and on forever. And this would be a series because we are adding them together. Okay, so that's just a little bit of vocab. And, if I was taking notes, I might just have these examples there, and hopefully that'd be enough. Or don't write anything down and just reference them from the PDF notes. Okay, so finding the sum of a finite arithmetic. So this would be a series that ends and is an add-subtract pattern. All right, and so each part, so this is just saying S of n is the sum of the first n terms, or the sum of however many terms are in the series. N just stands for the number of terms in the series. So for summing 8 terms, n would be 8, and then you'd have s sub 8, the sum of 8 terms. All right, a1, we should know that already, is the first term in the series, and then an actually is the value of the last term. All right, so I could even say, let's just say value of first term. So a1 will just be the value of the first one, an will be the value of the last, because if you have 8 terms, an would be 8, 8. That'd be the value of the last term. So this will make more sense as we do some examples, but that's the formula we're going to need for these questions. All right, so I thought just to make sense of this, I would start off with like a simple example where we could actually just add these together on our calculator. Okay, so we're going to do that and then check it and see if we can do the formula and make sure we get the same result, just to kind of make some sense of this formula. Okay, so one way to do this would be just to type them all in on our calculator, right? And we can see that the sum of that series is 60. All right, so we know that our answer is essentially going to be 60. That's the sum. But let's try it now with the formula. Okay, so I'm going to, again, these are our AN values, and these are our positions. So we have 1, 2, 3, 4, 5, 6. Okay, so in our formula, we are doing the sum of 6 terms. And I'm going to maybe, if you feel like you got it, pause the video and try, right? This one's not too bad. See if you can fill in N, A1, and AN, and then go from there. All right, so we would have 6 over 2 because we have 6 terms, right? And then A1 is just the first term, 5. And AN in this case, because we're doing 6 terms, AN is really A6, which is the last term, 15. So again, this AN just stands for the last value. Okay, so now we're pretty much done. This is just 3. 6 divided by 2. 5 plus 15 is 20. And then you multiply those together, and you get 60, just like we got when we did it sort of the manual way on our calculator. Just if you want a little picture of why this formula makes sense real quick, we essentially have 3 20s. And if you look, this will be true of any arithmetic series. If you combine these two together, that's 20. And then you go in one from each side, 7 and 13 makes a 20. And then I ran out of space here, but the 9 and 11 makes one more 20. So that's why we essentially have 3 20s, right? You're kind of adding the pairs of numbers, and then you have half. The number of pairs you have is half the total numbers in the sequence, 6 divided by 2. So we have 3 20 pairs. That's why we get 60. So, you don't have to know that necessarily, but I thought that's kind of a cool picture of why this formula, why it's n divided by 2. It's sort of averaging these first and last term, and then you go in one more pair, and it's the same sum each time. All right, so let's look at a longer one here. And again, you could start to type this all in your calculator if you wanted to, but as it gets longer, you're going to be much better off using the formula. Okay, so this is another basic one, so try it real quick. See if you can find the sum. Instead of typing it all in, use a little formula. Okay, so let's take a look at how many terms we actually have. 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be n, right? So we're finding the sum of 12 terms, and we have 12 divided by 2. A1 is 2. AN would be the last term, 35. Okay, so basically we have 6 37s. Okay, and again, where that formula is really coming from on this is the fact that 2 and 35 make 37, and then 5 and 32 make another 37, and then if we went in again, 8 and 29 makes 37. So you basically have 6 37s, 6 pairs that make of 37s. And you multiply those together, and that'll get you the sum. 6 times 37, 222. And we could verify if we really wanted to add them all together manually. All right, so now we just got to apply this formula to some kind of trickier situations. So now I have to find the sum of all the even integers from 2 to 100. So basically I'm trying to find 2. This is what my series would look like. It's arithmetic series again. That's what we're doing. An add or subtract pattern. We're going up by 2 each time. All right, and we've got to find the sum of all those numbers. So pause the video and see if you can use the formula. All right, so the first thing is we've got to figure out how many terms are in this sum. Okay, so if you think about it, we have half of the numbers between 1 to 100, so we'd have 50 values. So n would be 50. Right, so we're trying to find the sum of 50 numbers because we only have half. We have the evens. So we'd have 50 over 2, and then my first value is 2. My last value is 100. So A1 is 2 and AN is 100. And now we just crunch on the calculator. So it's 25, 50 divided by 2 times 102. So we get 2,550 for our sum. Pretty big, but I guess it would make sense if you look at all the numbers we're adding together here. All right, so find the sum. This is starting to get pretty tricky, but I'm going to have you try this as much as you can, and then we'll kind of piece the rest of it together. So try what you can here. It's a good challenge for you, and then unpause the video and see the solution. Okay, so the tricky part on this is what is n, right? How many terms are there in the sum? We know this is the first term. We know this is the second. We know this is the third. But because of the dot, 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 we don't know what n is out here, right? So I'm going to leave that blank for now. We don't know what n is, but we do know a1 and an, right? A1 is just 4, and an is the last term, 99. Okay, so essentially we just got to figure out what is n. Okay, and so how we do that is we're going to go back and we're going to use our explicit formula, right? So if you remember, for an arithmetic sequence, that is the formula for an arithmetic pattern. Okay, so I'm just going to write out an, and you could again pause and try it before you watch the answer, right? But we do the first term plus the common difference looks like it's 5. So we start at 4 and we go up 5 n minus 1 times. Okay, and I'm going to do my cleanup here real quick. So I'm going to do an equals 4 plus 5n minus 5. Then combine the 4 and the negative 5. Okay, so then the question becomes, how do we find like this value here? Okay, and this is where I think it's super important. I know these are kind of flipped this time, but to understand that these red numbers underneath here are the n values, and then an are these numbers up here. These are the values, and these red things are the positions n. Okay, so we don't put 99 in for n because 99 is an an value. We want to know n, the position for 99. So we're going to put 99 here for an, and then work backwards to find n. What is its position? Right, so if I put 99 for my an, I would just add 1, so I'd get 100 equals 5n, and then divide by 5 to get 20. And I'm sorry this is backwards. Normally I have n on the top and an on the bottom, but I couldn't fit them up here. So anyways, that means n is 20, which tells us that this is the 20th spot. Maybe I can label them across the top. That's how I normally do it. All right, so now we have 20 terms in our series, and now we're in good shape because now that we know n is 20, we can go back to our formula. Okay, and so we get 10, and then 4 plus 99 would be 103. And then you multiply those together and you get 1,030 would be our sum. Sorry for the bad handwriting there, but that would be the sum of that series. Okay, so I'm going to have one more. I'm going to kind of fast on this because I'm running low on time, but pause the video and try to find the sum of this series. It's a lot like the last question, but this is the hardest type question in this lesson, so I'll give you a chance to try one more. Okay, so again, when we do the sum here, we know the first and last term. We know the first term is 5. We know the last term is 131, right? But the tricky part is we don't know how many terms there are. Okay, so we've got to find n for this 131 value. Okay, so I'm going to go back and do my explicit formula. So an 5 plus 2n minus 1. All right, start with 5, go up by 2, and then I'm going to clean this up. I'm going to go speed mode here. I think that would be 3 plus 2n. If I distribute the 2 in, right, that would be my formula. Okay, so now I got to find n for 131. So that's going to be an an value. So I plug it in, and then crunch, crunch, crunch. So it'd be minus 3 divided by 2. So basically that tells us that 131 is the 64th term. Right, so if I put 64 in there, so I have 64 terms, so that means it'd be 32 times 136, and multiply those together and you'll get the sum. All right, so this would be a sum of 64 terms here, and it would just be 4,352.